Calc Nerds. This is going to be your notes for Section 2-1, Day 3. Now, yesterday in 2-1, Day 2, I hope you've already watched this video, and I showed you all these limit laws. All these limit laws, things that you can do legally with a limit, and then I said, by the way, you can just try plugging it in and see what happens when you're finding a limit. You can just try plugging in that number into your function and see what happens. And some of you are like, why didn't you just tell me that in the first place? Well, the reason we're able to do that is because of all those limit laws. So, and these limit laws were important. We're going to be doing like other things where we're going to use similar laws to our limit laws. You're going to be like, oh, I kind of think I've seen that before back when we were doing limits. So they are good to go over as well. So direct substitution, we're going to use this a lot, but it sounds easy. But yeah, we're going to use direct substitution a lot, but in most cases, it's not going to work. So in most cases, we're going to try plugging that number into our function, and we're going to blow up. We're going to end up dividing by 0 or square rooting a negative or something like that. It's not going to work out for us most of the time. So today I'm going to show you like more ways to evaluate a limit, still without a graph. So we are on 2-1, Day 3. And here's what this thing in the box says up here. If you are trying to find the limit of a function and it's not working out well for you, if you can find another function that's equal to it, then you can do the limit of that function instead. Okay, sorry about that. So, that's what we're going to do is we're going to take a function, and it's not going to be working out for us really well when we do direct substitution, so we're going to like change the function legally. We still want the new function that we create to be equal to it. It's just going to allow us to plug in our value better. So these are the steps that we're going to take to evaluate a limit. Plan A, we're going to try direct substitution. We're going to take that number, we're going to substitute it in, cross our fingers, and hope that we don't blow up. Most of the time we will. So then we go on to Plan B and we go on to Plan C. Pause the video for a moment and copy those steps on your paper. Now, in example A, we are trying to find the limit as x approaches 1 of this function. So as x gets close to 1, I wonder where my y values are headed in this function. Now, I'll go ahead and say I did try direct substitution. So you can see really quickly without like writing anything out, the moment you plug 1 into your denominator, so direct substitution is not going to work in this problem. So, now before we get started, do any of you know what this function looks like? Like if you were to graph it, not using a graphing calculator, just your knowledge, do you know what it would look like? I bet most of you don't. So, let's see. I think you might be able to figure out what it looks like by the time we get to the end of the problem. Let's start evaluating our limit according to our steps that we have. So Plan A, direct substitution, that didn't work. Plan B, we are going to take this function and manipulate it legally any way we can so that the denominator does not contain x minus 1 anymore. Because if the denominator doesn't contain x minus 1, more than likely I'll be able to plug 1 in to find the limit. So what I've done is I tried factoring the numerator and I left the denominator the same. And now here's what most of you are seeing. You're like, oh my gosh, I can cancel these two binomials. Well, you can. I kind of hate to say the word cancel because really when we do that, we're dividing by 0 and we're blowing up. So here's the way I want you to think about it. Do you remember in pre-cal when you looked at rational functions and you said, what makes the denominator 0? 1, obviously. Does that number make the numerator 0 also? Yes, it does. So when you have a number like 1 that makes the denominator and the numerator equal 0, do you remember what's going on in that graph right there? It's either a vertical asymptote or it's a hole. So basically, in this case, it's a hole because I see this both places. X equals 1 is going to make my denominator and my numerator 0. A hole occurs there. If it only made the denominator 0, it would be a vertical asymptote at 1. But since it does both, it's a hole. So here's what I'm going to try to get you to say in your mind instead of canceling. I'm going to try to get you to think, ignore the hole that's in this function. If I ignore the fact that there's a hole there, look what here's what the rest of the function is. This is what's going on everywhere else. There's a hole at 1. So now we're ignoring this hole, which is causing us all kinds of trouble. It's causing us to blow up, all that stuff. Now, try direct substitution. See how that works for you. So these factors right here, you know what they do? They cause all kinds of problems. Here's what's going on in this problem. We have a line. We have mx plus b. We have a line with a y-intercept of 1 and a slope of 1. Okay, it's a line. Simple, so simple. But you know what else is in that graph? There is a hole at x equals 1. In fact, the x value where the hole exists is 1. What's the y value where the hole exists? It's 2. So, will this function ever have a point, 1, 2? No. The y's will never attain a value of 2. They're just going to get close. My x's can never have a value of 1. They can just get close. My x's are going to get close to 1. My y's are going to get close to 2. But there's a hole at 1, 2. Okay, so quick recap. I tried direct substitution. Plan B is work some algebra magic. Factor it, cancel it, ignore the hole. We're going to try all kinds of other algebraic stuff to try to be able to dwindle this down, manipulate the function into something where I can use direct substitution without blowing up. That's the plan. Let's move on to example B. Kind of a complicated function. I already tried direct substitution. Found out that I would blow up if we tried plugging that in. So it's our job to legally manipulate this function, work some algebra magic on it, so that I can plug in 0 for h. So let's see, what could we possibly do to change this function around? Well, be careful. Don't you dare try to cancel out those h's. You're going to kill like the cutest kitten ever if you try to cancel out those h's. This h is trapped inside a binomial. You can't do that. So that's not an option. You can't subtract 9 from anything in here because this is a quantity that's being squared. I think your best bet is to square this and see what happens. Like, go ahead and FOIL this out and see what you get. Okay, so I'm going to FOIL this, and I get 9 plus 6h plus h squared. Please tell me you can do that in your head. All right, so I FOILed that out. Now, I see that I can collect some like terms here. Limit as h approaches 0. My 9's cancel, so I've got 6h plus h squared all over h. And I think I can go ahead and cancel. I think for you all, I would not do this in pre-cal, but I think for you all, I can go ahead and say, you know what? This term has an h, this term has an h, this term has an h. Go ahead and take out an h, like cancel out an h. In pre-cal, I would probably make them factor the h out and then cancel, but y'all are algebra experts, so I think we're good here. Take out an h. We get the limit as h approaches 0 of 6 plus h and no denominator. So now we can use direct substitution. And the limit is 6. So again, here's what's happening. In this function, as h gets close to 0, my y values will be getting close to 6. But I don't think that the point 0, 6 exists. There's something there, probably a hole. All right, something else to point out. When you show your work in math, most of you do your math vertically. So you set up your problem, whatever you do to it, you're doing it in the next line or next couple of lines down, and then you work your way down, you work your way down, you work your way down. For those of you who squish all your work into one single row on lined paper and you work it all the way across, keep in mind that your math teacher might not be the youngest person in the world. Your math teacher might wear glasses. Your math teacher might be close to 50 years old, and she might need a magnifying glass to see what on earth you're doing. So, anyway, this is the way that technically we like to see work being shown. And every time you make a new line in math, you rewrite your problem, you rewrite it, you're saying, hey, this line is an equivalent statement to that line. My next line is an equivalent statement to the one above it. This line is an equivalent statement to the one above it. If you decide to be lazy, and leave off the limit each time, you're like, I don't want to rewrite that every single time. Well, you're wrong. You're going to be counted off. This is not an equivalent statement to that. You have just taken a problem that is a limit. As h gets close to that, where are my y's headed? And now all of a sudden you've just turned it into some algebraic expression that you're just playing around with. So make sure that you do a rewrite each time using the full problem. It is a limit problem. Okay, moving on. The next one, try direct substitution. That doesn't work for you. Here's what has to happen. This t squared in the denominator is wreaking all kinds of havoc on this problem. Like I can't plug in 0 because of this. So one of two things kind of needs to happen. One is I'd like to be able to maybe cancel this with something on top. Well, I can't right now. I cannot cancel. Or if there was extra stuff in the bottom, extra math to do, so that when I plug in 0, I'm not just plugging in 0. Maybe I'm like adding 10 to it or something. I don't know. So either get rid of it or create more stuff in the denominator so that you're able to plug in your number. Well, create more stuff legally. You can't just put a plus 10 on it. All right, so direct substitution didn't work. Algebra manipulation, this is not factorable. But here's one thing I want to point out. This t squared is in a radical, and plan C was rationalized the numerator. Kind of weird. Most of you in pre-cal, this would be in the denominator, and you would rationalize your denominator. Now I want you to try to rationalize the numerator. So here's what's gonna happen. I am going to, in order to rationalize this numerator, hang on, let me get this out of the way. Okay. In order to rationalize the numerator, I need to multiply top and bottom by its conjugate. So if you remember the conjugate, first term is the same, last term is the same, the sign in the middle is different. So I'm going to multiply by the quantity, radical t squared plus 9 plus 3, and also in your denominator. Multiply by the same thing, that's keeping it legal. I know you don't want to, but rewrite the fact that we're doing a limit here. Okay, so in my numerator, I have this quantity, a binomial, times this quantity, a binomial. You need to FOIL. You got a binomial and a binomial, you're multiplying them. You need to FOIL. But when we FOIL, in this case, remember how you deliberately made this one a plus in the middle? The reason you did that is so that your O and your I will cancel out. So we're going to go first. We're going to multiply radical times radical. When we do outer, we get a positive term. When we do inner, we get a negative term. They're going to cancel out. And then we're going to do last. So basically, all we need to do is first and last, because our outer and inner are going to cancel. So first, we are looking at t squared plus 9 without the radical on it. And last is going to result in a negative 9. Now, for your denominator, yeah, you're multiplying t squared times this binomial, but hang on a minute. Don't actually do the multiplication yet. Like, don't distribute it in. Just write it like this. And hopefully you see why. The 9s are going to collect and go away. Your t squareds will be able to cancel. So I've got the limit approaches 0 of 1 over radical t squared plus 9 plus 3. Now try direct substitution. Plug in 0. 0 plus 9, square root that, that's 3. 1, 6. So as t gets close to 0, these y values are getting really, really close to 1/6. Y'all know what 1/6 is as a decimal? See that function right there? If I pull up yesterday's notes, does it look familiar? So yesterday we just tried to guess on our graphing calculator, and remember it was kind of hard to guess. Well, today I showed you how to rationalize the numerator so that you could use direct substitution, just plug that 0 in. Pretty cool, huh? All right. Couple more. I tried direct substitution here. Of course, that didn't work. And so let's try to manipulate our function legally. Manipulate our function. So, rewrite. I think some of you, since 7 is to the -1 power and x is to the -1 power, I think some of you are going to be like, oh, I know, you move that to the denominator. True, kind of. But you don't just, you can't move this 7 to the denominator and this x to the denominator. That's not legal. Here's what I think you're thinking of doing. If the whole quantity were to the -1 power, you could move the whole quantity to the denominator. It's each individual term that's to the -1 power. So, that's a bad idea. That's a bad idea. So what we're going to have to do is look at each term in its own little fraction. And here's what I mean by that. Take the 7 to the -1 power. Currently, it's 7/1. It's a tiny little fraction, 7/1. Move the 7 to its own little denominator. Here's what it looks like. Do the same thing with the x. The x here is its own little fraction, x to the -1. Move it to its own little denominator. That's the legal way of doing 7 to the -1 and x to the -1. It's a binomial, and each exponent is on each term individually. So you have to do them individually. Okay, now, still doesn't help us. I mean, I still try direct substitution. I still got stuff going on in the denominator. So what we're going to do is think about what I just did from this line to this line. I just put miniature fractions inside a big fraction. So we had this big fraction going on, and I just created miniature fractions within it. I want them to go away. I want to try to get rid of my miniature fractions. How do you get rid of a fraction? You multiply by its denominator. So this one has a denominator of 7. This one has a denominator of x. I would like both of these fractions to disappear. So I am going to multiply my numerator by 7x. If I multiply both of these terms by 7x, I won't have fractions up there anymore. But wait, keep it legal. If I multiply the numerator by 7x, I have to multiply the denominator by 7x. Here I go. Seven x times 1/7 is just x. 7x times 1 over x is just 7. On the bottom, don't actually do the multiplication. Don't multiply this by this. Just write it out. See? This is here. This was here. Okay? I did multiply through on top. I didn't multiply through on the bottom. That's a common theme. We're not gonna multiply out our denominators unless we have a really good reason to do so. And here I have a really good reason to not multiply out my denominator, because you can see that this binomial cancels with this binomial. Or we are ignoring the whole. And so our new similar function is just 1 over 7x. Substitute that in. And I get 1 over 49. Last problem. I tried direct substitution. That didn't work. I'm going to try taking this function right here and splitting it into two pieces. So this is legal if you have like several terms on the top and only one term on the bottom, you can split it. So I'm going to go limit in fact, not only am I going to split it into two fractions, I'm going to split it into two limit laws from yesterday. So my first limit is going to be this one over this one. That's going to be nice. And my second one is going to be the limit of this one over this one. Okay. Now, a couple things I'm going to do here. I canceled the 2's, reduced one of my x's, so I just got the limit as x approaches 0 of x. We're gonna do that limit here in just a minute. And then right here, do you remember, it was yesterday, that one I had you memorize? But here's the catch. It has to be the limit as x approaches 0. Good, that's what we're doing. Whatever this is, this has to match. Do they match? No. That's a 3x, that's 2x. So here's what I'm going to do. I'm going to pull off my constant. So, like, there's like a 1 here, and there's a 2 here. I'm going to pull off a 1/2, a constant of 1/2, and put it out in the front. And now I have sine of 3x over just plain x. I know, they still don't match, but we're getting there. We're getting there. I'm going to show you how to force them to match. All right, so let's go ahead and do this limit first, because we're going to knock this one out and we won't have to write so much. The limit as x approaches 0 of x, this is just 0. Also, keep in mind that when you have a trig function, you can't touch the angle. I can't pull the 3 out here. It's not a coefficient. It's an angle. It's an angle. You can't touch this angle. So sine of 3x, that's going to stay 3x the whole way through. I can't touch it. Can't manipulate it in any way unless you want to like use some trig identities way back from pre-cal, and oh my goodness, who wants to do? We don't want to do that. Let's just not touch the angle, okay? We're not going to touch the angle. Here's what we're going to do. I think you can legally put a 3 there, as long as you put a 3 here. I just multiplied this fraction by 3 over 3. Totally legal. I just multiplied it by 1. I just multiplied by 3 over 3. Now, here's what I want you to do. Leave this one with the x. We need it. Pull this one off. Now they match. And it's a limit as x approaches 0. Sine of, these are the same, so the answer to this part right here is 1. Okay, so I have 3 halves. The answer to this is 1. Multiplication, it's coefficient. The answer to my limit is 3 halves. Okay, so all stuff that I know you're able to do, like I know you're able to split up a fraction that has a single term in the denominator. Y'all can do that. I know that you can recognize that this is 1/2 and pull that coefficient off to the front. I know that you know that you can multiply a fraction by 3 over 3. It's all stuff that you know you can do. You probably just wouldn't have thought to do it. You're probably looking at this and thinking, oh my gosh, I would have never thought to do that. No, you wouldn't. That's why we went over it in your notes. Now, you'll think to do it when you need to. All right, so good luck with that. Hope it works well for you. I do expect, for some of you, this might be the first day that you get stuck on something. So the homework for day 1, the homework for day 2, I think was pretty easy. I think this will be the first time that I stump some of you. Not everyone. Some of you are going to breeze through this, and some of you are going to be like, Ms. Neal, I thought you said calculus was hard. You haven't challenged me yet. I will. It may be today, it may be later, but you'll get there to where you're stuck, and that's when you come to me with questions. So go back over your notes, go back through. Is there anything I'm missing? Better talk to her. I'm not going to tell you exactly what to do, but I'll ask you questions so to lead you into thinking the right way. Okay? Good luck to you.